So, the magnetic fields of the Earth are generated from the rotation of the Earth. There is something very interesting that is happening with the magnetic fields of the Earth right now. Researchers have known for years that the faster the Earth rotates, the stronger the fields, and the slower the Earth rotates, the weaker the fields of the magnetics are. Okay, now that's important. And look at this. In this image, what you're seeing here, this red line is a line of the magnetic fields of the Earth through time. Time is passing in this direction. Right here, this is the present time today. Now we're looking 2,000 years ago. And what we see is that 2,000 years ago, the magnetic fields were at a peak. They were higher 2,000 years ago than they had been for a long, long time. And they were higher 2,000 years ago than they have been at any time since then. And what we can say is this. We can say that 2,000 years ago, Earth had the strongest, the densest magnetic fields. Earth was rotating faster 2,000 years ago, generating those strong magnetic fields. And then something began to happen. As you can see, the magnetic fields are dropping. Well, if the strength of those fields is tied to the rotation of the Earth, and the faster Earth rotates, the stronger the fields are, when you see low fields, what you are seeing is a decrease in the rotation of the Earth. And that's precisely what is happening. Earth right now is slowing down. It rotates slower and slower each year. Our researchers know this. Researchers know this. They measure this, the National Bureau of Standards in Boulder, Colorado. Every year, they must adjust the atomic clocks, the cesium-based clocks that keep track of our time. They have to adjust those clocks to compensate for the slowing of Earth's rotation. Now, admittedly, it's not very much that they have to do the adjustments. They're very, very small, incremental periods of time, and those periods of incremental time are cumulative. They add up over long periods of time. And the researchers actually say, they say that if we did not do that, by the end of this decade, what used to be noon would become midnight. That's how much of a change the rotation has, the effect that it has on our keeping of time. Well, if we're seeing this magnetic field decrease, what we're seeing is the slowing of the rotation of the Earth. So on our little board over here, I have you see this red line represents the intensity of the magnetic fields of the Earth as time increases in this direction. Okay, so here's the magnetic fields on this scale here. Here is no magnetics, a 0-point magnetic, and we're somewhere around in here. We're losing, excuse me, we're losing magnetics very, very quickly. The interesting thing is that it is not a linear drop. Researchers can't look at where the magnetics were 50 years ago and then look at where they are 5 years ago and draw a straight line and say that's where they're going to be 5 years from now. It is not a linear function. It is a geometric function. I hope that's an erasable pen that we have on here. It's a geometric drop that we're seeing on these magnetic fields. So you say, well, how much are these fields actually dropping? Right now, we're experiencing about 50% less magnetics on our planet than we did only 1,500 years ago. 50% less. And it appears that we're losing around 5 to 6, maybe 8% of the magnetic field every 100 years up until fairly recently, and now we're losing even more. It's happening quicker. So what we can say is the more that the fields drop, the faster they drop. Through mutual friends, I had the opportunity to talk about this information with someone from the GeoMonitor organization. They keep track of things like this kind of information, magnetics, frequency, and such. And they said, yes, in fact, the Earth's magnetics are dropping very quickly. And they said two very interesting things that I'll share with you now. First thing they said was that any time in recorded history that Earth's magnetics have dropped to this degree, it has always been a precursor to a 180-degree polar reversal, to the North Pole becoming the South and the South Pole becoming North. You'll see the mechanism for that in just a moment. And the second thing that they said I think is really interesting. What they said is this. When someone asked them how low the magnetics of Earth are actually right now, what the geomonitor people said was this. On a scale of 1 to 10, with 10 being the highest readings, the strongest magnetics, right now, early 1996, Earth is between a 1 and a 1.5 on this scale. That is how low the fields are in a relative sense. And they're continuing to drop. Okay? Now, the interesting thing about this is that this is not new. Earth's dropping of the magnetic fields is not a new